Welcome to Alphanumeric Tricks. In this video, we are going to see the topic standard types of first order nonlinear partial differential equations, which is of the form f of x, y, z, p, q is equal to 0. This is the continuation of the previous video. In previous video, we have seen that how to get the solution of two types of problems, namely f of p, q is equal to 0 and Clairaut's form time. In this video, we are going to see how to get the solution of remaining standard types of problems. That is, in type 3, we have three cases. Case 1 is f of x, p, q is equal to 0, and case 2 is f of y, p, q is equal to 0, and case 3 is f of z, p, q is equal to 0. And type 4 is separable equations, f of x, p is equal to phi of y, q. And last type is type 5, equations reducible to standard forms. We will see how to get the solution of these type of problems one by one now. Here the methods to solve standard types of first order nonlinear partial differential equations are given, and which is of the form f of x, y, z, p, q is equal to 0. Here the partial derivatives p and q may occur other than in the first degree. Now we will see how to get the solution of type 3 problems. That is, type 3 we have three cases. Case 1 is along with p and q, x alone is present. That is, f of x, p, q is equal to 0. And case 2 problem is along with p and q, y alone is present. That is, f of y, p, q is equal to 0. And case 3 problem is along with p and q, z alone is present, and x and y are not present in your problem directly, which is f of z, p, q is equal to 0. Now we will see how to get the solution of our working rule for the case 1 problem, that is f of x, p, q is equal to 0. Here we have to find out the complete integral, singular integral and general integral for these type of problems now. First we will see how to get the complete integral. To find the complete integral, we have to assume some terms. That is, since z is a function of x and y, so you have to take dz is equal to pdx plus qdy. And you have to assume one more substitution, that is one more assumption. You have to take q is equal to a. How you can remember this is x and p are related, that is p is dou z by dou x. So x and p are related. So the separate term here is q. So for that term you have to substitute a. Okay, q is equal to a we have to assume. Then why we are substituting here is, using this substitution we have to find that is this q is equal, after taking q is equal to a, we have to substitute this in case 1, that is our problem, case 1 problem. Find out the value of q, and using p and q in dz is equal to pdx plus qdy. After integrating, you can get the complete integral. For that only we are assuming these things. Okay, now you have to substitute q is equal to a in our problem. Then your problem becomes f of x, p, q is replaced by a is equal to 0. From this equation, you have to find out the value of p. So we get, that is how it is possible is, you have to keep p left hand side and remaining terms to right hand side. Then you can get the value for p, which is equal to phi of x, a. Why we are using different function phi, not using f here is, when you're taking other, that is x and a to your right hand side, you get a different equation. And that's why we are not using the same function, we are using different function phi here. Now you have to substitute q, p and q values in dz is equal to pdx plus qdy. So dz is equal to p value is phi of x, a into this dx plus q value is a into dy. When you integrating this, you get the value for z, that is your complete integral. So integrating integral dz becomes z because differentiation and integration get cancelled, which is equal to integral phi of x comma a dx plus a dy. This is under integral sign plus c is constant of integration. And when you integrating this phi of x comma a dx, here after integrating you get the some other result you got it. That result is a function of x and a only. That's why you can replace this integral phi of x comma a dx as f of x comma a plus a into integral dy is y plus a constant c, which is your required complete integral. Number that equation as 1. Now using this complete integral, we have to find out the singular integral and the general integral. We will see singular integral now. For that you consider the complete integral is it is equal to f of x comma a plus ay plus c, because using this only we can find out the singular integral. How we can find out singular integral is you have to differentiate this with respect to the arbitrary constants a and c, and you can get the using a rule you can get the singular integral. What is the rule we are using? Dou z by dou a is equal to 0 and dou z by dou c is equal to 0. That is, it is differentiated with respect to the available arbitrary constants partially and equated to 0. Okay, so this rule is used here to get the singular integral. Now we will see how to get the singular integral. Differentiating one partially with respect to a and c. Here it is not possible, that is it is no need to find out the differentiation with respect to a, because whenever your complete integral is having a constant is a single constant is there, then when you differentiating that constant with respect to that is z is differentiated with respect to that constant, then you get 0 is equal to 1 result, because dou z when you differentiating this with respect to c, dou z by dou c is 0 and c with respect to c is 1, so you have 0 is equal to 1 result is obtained, which is observed result. So in that case we can't find out the singular integral. So you when you are doing problems also, if your complete integral is having a single arbitrary constant, then you can write this way, that is we can get differentiating this term with respect to c, we get the result 0 is equal to 1, which is observed result. So there is no singular integral for the given case 1 problem. Okay, we can conclude like that. Now we will find the general integral for this case 1 problem. F of x comma p comma q is equal to 0. As usual, general integral is you have to reduce two arbitrary constant to single arbitrary constant by the substitution taking of one function, that is one constant to be a function of the another one, that is c is equal to phi of a. Substituting this in the complete integral 1, we get z is equal to f of x comma a plus ay plus c is replaced by phi of a. Now you have to number that equation as 2, and this is differentiated with respect to the available arbitrary constant a, and dou z by dou a value is 0, because using this rule dou z by dou a is equal to 0 is equal to differentiation of f with respect to a partially is f dash of x comma a plus differentiation of ay with respect to a is y, because y is constant, a with respect to a becomes 1, plus differentiation of phi of a with respect to a is phi dash of a. Number that as 3. Using 2 and 3, we try to eliminate the arbitrary constant a, then you can get the general integral for the case 1 problem, that is f of x comma p comma q is equal to 0. Now we will see case 2 type of problems. F of y comma p comma q is equal to 0. How to get the solution of this type of problems now. Here also the singular, complete and general integrals are as usual method, we have to find it out, but only thing is the substitution is different here. So we when finding complete integral, so we have to assume that p is equal to a to find the complete integral. How you can remember is, here y and q are related, so separate term here is p. So for that p you have to substitute a, that is p is equal to a, you have to assume, not substitution, you have to assume p is equal to a. Then your given problem becomes f of y comma a comma q is equal to 0. That is, instead of p we are taking a is equal to 0. From that you can get the value of q. So q is equal to phi of y comma a, and you have to substitute p and q in where, which equation? Is dz is equal to pdx plus q dy, which is equal to p is replaced by a into dx plus q is replaced by phi of y comma a into dy. When you integrating this, you can get the complete integral. Integrating, you get z, the integral dz is equal to integral a dx plus phi of y comma a dy plus a constant of integration, and here integral z is equal to a into integral dx is x plus phi of y comma a dy integration is, again integrating this you get some other function of y comma a. The resulting term is a function of y and a. That's why we are using f of y comma a after integration, after integrating phi of y comma a dy plus this constant of integration c. This is our complete integral for the case 2 problem, f of y comma p comma q is equal to 0. Now we have to find out the singular integral. Here, for the singular integral is possible or not? It is not possible because c is separately there, the constant, arbitrary constant c is separately there. So when you differentiating this complete integral with respect to c, you get the result is 0, that is dou z by dou c is equal to 1, but dou z by dou c is equal to 0 using the rule. So we get 0 is equal to 1, we get an absurd result. So there is no singular integral for this case 2 problem, case 2 type of problems. And general integral is as usual, that is like your previous case 1 time, you can find out the general integral. Now we will see how to get the solution for case 3 problem, f of z comma p comma q is equal to 0. Here also the same procedure for case 2 we have to apply here. That is, assumption only is different to find the complete integral. What is the assumption we made here is q is equal to ap. In the z alone is present, that is z pq is equal to 0 is present in your problem, then you have to assume the substitution q is equal to ap in your given problem. Then it becomes f of z comma p comma q is replaced by ap is equal to 0. As usual, from that here also we have to get the value of p. So solving for p, we get p is equal to phi of z comma a. Then you have to substitute p and q values in dz is equal to pdx plus q dy, which is equal to p dx plus, but we make the substitution q is equal to ap here. So after substituting this, p is common, so take it outside. So when you are taking outside, dz is equal to p into dx plus a dy. But what is p value? Phi of z comma a, that is substituted here into dx plus a dy. Now phi of z comma a is you can separate the terms, that is phi of z comma a is taken to the left hand side denominator. So after that you have to integrate it. So integrating, integral dz by phi of z comma a is equal to integral dx plus a dy plus a constant, because when you taking this z terms to combine z terms together, then integration becomes easy. That's why we have to take that phi of z comma a to left hand side denominator, that is you combine z terms together. Now after integrating, you can get the complete integral. If you know the function phi of z comma a, then you can integrate, and that is according to that function only we have to integrate the left hand side term, and right hand side term you have as x plus ay plus a constant. Here also there is no singular integral because c is separately occur. So 0 is equal to 1 result is obtained, that is absurd result we can got it after differentiating with respect to the c. So we conclude that there is no singular integral for this type of case 3 problem also, and the general integral is as usual we have to obtain. Now we will see type 4 problem, that is separable equations, which is of the form f of x comma p is equal to phi of y comma q. Here z is not present in this type of problem, and you have to combine x terms together and y terms together before starting to find the complete integral. Now we have to find the complete integral for this type of problem. How to get the complete integral is, here also we have to make use of the that is, we have to substitute this term to be a, that is, given problem is equal to the constant a, because you are after grouping, that is, x terms together and y terms together, you have to equate that to some other constant a, and then you can separate this, that is, 3 terms is equal, so you can write that f of x comma p is equal to a and phi of y comma q is equal to a. You can write this way. From that we can find out the values of p and q. So p is equal to here, when you taking remaining terms to your right hand side, so p is equal to, we get another function. When you taking this right hand side alone, we are considering not, we get the same function, that is different one. That's why we are using f1 of x comma a, and when value of q is equal to phi 1 of y comma a. And as usual, we have to substitute this p and q values in dz is equal to p dx plus q dy. And when substituting, this becomes p value is f1 of x comma a dx plus phi 1 of y comma a dy. When you integrating this, dz integration becomes ez. So z is equal to integral f1 of x comma a dx plus integral phi 1 of y comma a dy plus a constant. When this term can be written as f1 of x comma a, and this can be taken as phi 2 of x comma a after integrating plus a constant, that is your complete integral. And here also there is no singular and integral exists, and the general integral is as usual, because why singular integral does not exist here is c is occur separately. So when you differentiating this with respect to the constant, then you can get the observed result 0 is equal to 1. That's why no singular integral. And general integral is like your previous cases, we have to apply the same technique here also. Now type 5 problem is equations reducible to standard forms. That is in physics, that is in practical situations, we can't predict that this all partial differential equations occur in these type 1 or type 2 or type 3 or type 4. We can't predict like that. It may occur different equations. So such type of equations, how to get us using that change of variables, you can reduce those equations into any one of the standard types available, and we have to try to get the solution. To get the solution, we have to rearrange the equation and we make use of some substitution to get the singular, complete and general solutions. When we are doing problems, we will see those type of equations. So many nonlinear PDE of the first order do not occur in any of the standard types. But in some cases, it is possible to reduce those equations into any one of the standard types using change of variables. Okay, so we have to rearrange those equations and using the simple substitution, it is reduced to given problem into any of the 4 types discussed, and we can get the solution. That's all for today's video. If you have any doubts in this, please provide in the comment section. Thanks for your time and thanks for watching. We will see in the next video with some problems under this 4 types of equations. Thank you.